Alright, scientific notation. It's a way of writing numbers that are large or very, very, very small in a different form. So here's what scientific notation looks like. It's one number, and then a little dot, and then the rest of the number. We don't include the zeros, though, because that's what we're trying to get rid of. Times 10, and then this is our exponent here, whatever we get. And what it is number of moves. Okay? So for this one, it's one number. Our first number is 3, so we put a 3, and then we put the rest of the number, not including the zeros. And you come up to the number, and you place the decimal where it's supposed to be. But with a whole number, the decimal's always at the end. So then what we have to do now is move it, and we're going to move it 3, 6, 9, 12 times. And that number of moves is what our exponent represents. 12. And that is scientific notation. It has to have that form. One number, rest of the number, times 10 to the number of moves. Alright? Because every single move that we do is actually a 10. If we move from the ones, we get to the tenths. That's 110. We go to another move that gets to the hundreds. That's another multiple of 10. Right? So that's all you have to do. So what's our first number on the next one? Sorry, first non-zero digit. 1. And then the rest of the number, not including the zeros, times 10 to the, and we now need to move it. So the reason we write this first is it can tell us exactly where to put the decimal right there. So I'm going to do it in threes again. 3, 6, 9, 10. 10 moves. But see how we went into a smaller direction? That's negative. If the number is a decimal that we're going into, you're going to move it negatives, because each of these that we move into is not a 10. That very first place value right here, this is a tenth, and the tenth translates into this negative exponent. Okay, so let me have you try some. They're all set up for you to do. Right down here. Don't go reverse yet. Just try these. So I'll get you started on the first one. First non-zero is 3. The rest of the number is 2, 3. Which means our decimal goes between the 3 and the 2, and our decimal is here. So now move the decimal and place the number of moves up there. So hit pause and try these. When you unpause it, all the answers will appear. Alright, there are your answers. So if you want to make sure you record them and check them, hit pause now, and you can check them. When you unpause, I'm going to move on to the next section. Alright, next section is the reverse now. Now we're going to take scientific notation and move it into decimal form. So the way we do that is this is basically just reverse. The last thing we did was to move the decimal and count the number of moves. So now we're going to take the number of moves and move the decimal. So this says we're going to move 6. And the nice thing here is if it's in the positive direction, a positive, you move it in the positive. If it's a negative, you move it in the negative. So 3.15, we move it 1, 2, 3, 4, 5, 6. That's 6 moves that direction. We fill them all with zeros. And our decimal is now here. We moved it from here to there, and that's where we have to leave it. So our answer is 315, 1, 2, 3, 4. And there we go. And now if it's a negative, we're going to move it 1, 2, 3, 4, 5, 6 in the opposite direction, filling in every single loop again with zeros. So negative 6 goes that way. And so that is our answer, 0.12345, So if it's a negative exponent, you move it to the left. If it's a positive, you move it to the right. And you are physically picking up that decimal and sliding it over to where it's supposed to be. Alright, so give the rest a shot. Hit pause now. Alright, those are your answers. So 5, you should have moved to the right 5. 15 moves for the 4. 4 moves for the 9, and it's always the decimal, it will be after the number. And then the decimal is also after the 3, so you move it to the left 6 times, which give us 5 zeros. Alright, thank you.